All right, well, good morning, everyone, and welcome back to another exciting day of mathematics. Whoop, whoop. How's everybody doing? Good, how's home play? Good? Yeah? All right. So our warm-up for today is warm-up number 66 is on your screen. Number 1 says use -1, 0, 1 to evaluate the functions f of x equals 2 to the x power and f of x equals 10 to the x power. Number 2, graph f of x equals x, then transform use g of x equals f of parentheses x plus 4 close parentheses, all of that over 2. And then to the side, we have a constant of -3. Number 3, rewrite each expression. Part A reads a to the -9. Part B is 10,000 to the 0 exponent. Part C is, in parentheses, 1/2, close parentheses, to the -2 power. And number 4 reads, if x to the 3rd times x to the 5th is the same as x to the 3 plus 5, which is x to the 8, then rewrite 2 to the exponent of x to the 6. All right, I'll give you guys some time to do that. You should be able to do all 4 of them by yourself, so copy that and go. All right, let's see how we did. So for numbers 1 and 2, you should be able to do those on your own. Number 1 is exactly the same as the previous one. If you notice, it's the exact same thing. I just wanted you to get practice on evaluating that. Number 2, it's f of x equals x. And if you guys notice, it doesn't have an exponent. That means it's a linear function. It's a linear function, but applied now using these transformations. Or I do want to go over number 3 and 4. Let me see. For 3a, what'd you get for 3a, Octavio?
I got 1 over a with 9th power.
Yeah, let's go. Pass someone.
Mia.
Mia, what'd you get for b?
1.
Let's go. Pass someone.
Addison.
Addie, what'd you get for c?
For that one, I got 4.
Yes, let's go. Now, just FYI, those of you that didn't get that, well, if there's a negative exponent outside of the parentheses and inside of the parentheses, the rational expression, such as 1/2, you do the reciprocal, which is 2 over 1, and distribute the exponent as a positive. So 2 and 2. So this becomes 4 over 1, which is 4. Pass someone, Addie.
Alyssa.
All right.
I'm not sure if this is right, but I got 2 to the x power and then over 6.
Close. So 2 to the x power, so far, so good. We got this. But now we have the other exponent, which is the 6. Notice over here we have x to the 3rd, which was x to the 3rd. But then the plus 5 became another x to the 5th. So what would you write here, Alyssa, for the second part?
2 to the 6th.
Yes, 2 to the 6th. Okay. So from there, guys, we can simplify 2 to the 6th, which is 2 times 2 times 2 times 2 times 2 times 2, which is 64, times, we bring this over 2 to the x. So for right now, we'll leave it at that for right now. All right. All right. So our agenda for today, we have warm-up number 66. Today, we're moving on, guys. Exponential functions. Let's go. Exponential functions. Like that, Alberto? Pretty good? Yes? Let's go. Rocking and rolling. And our home play for tonight is pages 643 and 644. All only. Pages 643, 644, all only. For tonight's home play, make sure you go to Canvas and you click on the tutoring session if you need assistance with that at 1:15 sharp. Hopefully like I said, I would be set up in my classroom by then. And yeah, so just go to the tutoring link in there. All right, I'm going to write that down. Yes. Asynchronous code. Write this down. Asynchronous 3QSWJ. 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 All right. So our last home play was pages 396, 397. So go ahead and take 1 minute, go to Canvas, turn that in. I'll give you some time for that. And as you do that, once again, reminder, our home play for tonight, 643, 644, all. And we're gonna get started as soon as you turn that in. I'll give you a minute. And once again, you need a Cornell note, Fair model, and at least 2 coordinate planes from -8 to 8. Copy that and go. So you should have turned in your home play by now and ready to rock and roll. Y'all ready? Yeah? All right, here we go. Our objective for today, I can graph exponential functions. I can graph exponential functions. So today we're moving on to a new concept. And as you can see, it's exponential functions. And today we're only going to focus on the graphing portion. I want to make sure we get really familiar with all the components. And so like that, we are able to move on to the next tasks or skills that we need to get to. Okay. And once again, it's very, very important that everything that I've been giving you on the warm-ups, you've been practicing, and also what's coming up in this session, because all that is part or essential part of logs or logarithms as we get closer to that. Okay. Here we go. So exponential functions, what are they? An exponential function is a function written in the form f of x equals b to the x exponent, or g of x equals a times parentheses b to the exponent of x minus h close parentheses plus k, where b is greater than 0 and b does not equal to 1, and x is a variable. And that's a lot. It's a lot to take in, yes. But you'll see how it's fairly simple right now when we get to the practice part. Okay, examples. F of x equals 2 to the x, and f of x equals 10 to the x. Now those two, do you guys see that those are pretty familiar? Yes? Yes, because I gave you those on the warm-up. Why was I trying to get you guys familiar with these two? Because these are the most common exponential functions that we use. These are the most common. So if you want to make a little note for yourself, most common exponential functions. And these, since these are the most common, and we're starting with these without anything else added or subtracted to it, these are our parent functions that we're going to be working with, these two, okay? However, let me show you what it looks like once they add more transformations. Look up, watch. Look at this one, g of x equals -2 times 3 to the exponent of x. That's one that's already transformed. Look at this one, g of x equals 5 parentheses 2 to the exponent of x minus 3 close parentheses plus 4. So these already have some transformations. However, these two down here are the most common. So make sure you copy that. All right. And just to add a couple more things to the notes, just to refresh your mood, look up right here. The b here of f of x equals bx on the definition, I want you to kind of like underline that in blue, arrow to the side, and we're going to give that a name for you that were listening before or that your teachers went over exponential expressions. This is known as a base, a base. Some of you are like, oh yeah, Mr. Q, I remember this. Yes. And in green, I'm going to box the x, known as the exponent. Exponent. The x is an exponent. So according to the definition, it says here that b, or the base, has to be greater than 1 and cannot be equal to 1. Also, it says that x is a variable, so the exponent has to be a variable. So let's look at the examples. Let's see, all these, does it have a base? Yes. This one has a base of 2. Does it have a variable as an exponent? Yes, and then -3. Look at this one. Base is 3 and the exponent of x, yes. These two, base is 10, exponent of x, base is 2, exponent of x. Okay, so now that we know what exponential functions look like, let's look at non-examples. We have 5 times, parentheses, 2 to the exponent of x minus 3, close parentheses, plus 4, and f of x equals x squared. Now, these are not exponential functions. These are not exponential functions. Look at them. Why are these not exponential functions? Let's see, help us with that, please. Danny, why are these not exponential functions?
There's no g of x or f of x.
So this one doesn't have g of x or f of x.
Yeah.
What else doesn't it have?
It's not an equation.
It's not an equation, okay? So one hashtag would be what? Hashtag equations or functions, okay? How about this second one right here? Help me with this one, Angie. Why is this one not an exponential function?
Because the x is the base.
Because the x is the base, and according to the definition, the x or the variable has to be the exponent. Yes, this one, x is the base, and the x should be the exponent. Okay, so to save some time, or for the sake of time, I want to get us started right away. Hashtag function or hashtag equation. Another hashtag is hashtag base plus number, not 1. And hashtag variable exponent, variable exponent. Okay. All right, so here we go. According to what we've been looking at, here's our general transformation rule. Here it is. Do we know what each parameter does? Yes, Mr. Huber. Okay, we've been working with this all year. Is that correct? Yes, Mr. Huber. Have I been giving you transformations every warm-up? Yes, Mr. Q. Thank you, Mr. Q, for giving us that practice. Appreciate it. Oh, you're welcome. I got you. All right, so let me show you now what the rule for exponential functions look like right underneath the general rule that we had before. Here it is. And if you notice, it has the same parameters, maybe in a different spot, but it still has the same parameters. So follow along and take notes just to make sure that we understand what each parameter does. So let's see. Alberto's going to get us started and say what K does. What does K do to any function?
Makes it go up and down.
Up and down, that is correct. So if it's a positive, it goes up. If it's a negative, it goes down. Okay, not bad, not bad. How about H right here? Even though right now it's up in the exponent area, but it's still H. What does that one do, Mia?
Side to side.
Side to side. Let's go. So if it's a negative, it goes to the left. If it's a positive, it goes to the right. Okay. And if you notice the parameter A, it's still the coefficient. So what does that one do, Addie? The parameter A.
I think that's the one that stretches or compresses it, right?
Yeah, stretch or compress, but in which direction?
Oh, vertically.
That is correct. Vertically. Yes. All right. So that's for A. So if that's true for A, it stretches or compresses vertically. What does B do? What do you think, Victor? What does B do?
I don't know.
Okay, help them out. Where are we at? How about Nathan? What does B do?
It stretches the function.
Stretches or compresses. Now, if A did it vertically, that means B does it horizontally. And if you notice, it's the same thing that we've been doing with other functions, but now applying it to exponential. Now, for today's session, though, K plays a second purpose. Now, that second purpose, you guys already know what it is because you've been doing the graphing portion, yes? So who can tell us the second purpose of K? Who's got it? You think, oh, I know, Jaziel, what you think?
I don't know.
What? Last night's home play, you don't know? What was K?
It shifts it.
The horizontal asymptote.
That is correct. Horizontal asymptote. Or our HA, which is Y equals 2. So for today, that even applies to today's function, which is the exponential function. So keep that in mind because we're going to use that for today's, okay? So let's get started right away. Let's do some graphing. So you have your coordinate plane on the left side or the right side, doesn't matter. Part A, I want you to write the function or the parent function, f of x equals 2 to the x exponent, which is one of the most commonly used exponential functions. This is our parent function that we're going to start with. Part A is f of x equals 2 or base 2 to the x exponent. And then get an input-output table run underneath. For the domain, we're using -2, -1, 0, 1, 2, and 3. And then for the range, we just write f of x, and we're going to come out with those values. Next to that, part B, I want you to write the transformation of the parent function. Now it's going to be g of x equals 2, base 2. But now the exponent, instead of just being x, is x to the -1, x to the -1. And it's the same table, same domain, but instead of f of x, now it's g of x, because now it has a transformation. We're going to do that in red. Next to that one to the right, part C, we have a new transformation from the original function. And now we have part C is g of x equals parentheses, base 2, with the exponent of x minus 1, close parentheses. But at the end, a constant of -5. Okay? And underneath, you have a table of same domain, -2 all the way to 3, and the g of x instead of f of x, and that's going to be for our blue. Now, once again, these two transformations, B and C, are going to be related to the parent function, which is on part A, okay? Copy that really quick, set that up, and then we'll get started with that. All right, so let's do this. So before we get to the graphing portion, I do want us to right above all of that, if you have space or somewhere on the top corner, whatever, let me make some space up here. I'm going to go ahead and write our general rule for exponential functions. So like that, we can see these three transformations or these three graphs according to, or the functions according to the general rule. So what was the general rule that we just wrote? So our general rule was g of x equals a times base b with the exponent of x minus h. Whoa. Exponent of x minus h. Oh my goodness. Close parentheses. And with a constant of plus k. All right. So here we go. So to get started, let's look at our parent function f of x equals 2 to the x power. You guys see that? We're working on this one. Okay. So let's look at it through the lens of our general form. Okay. So do we have a base? Let's see, do we have a base here? Yes, Mr. Q, the base is 2, and that's RB. There it is, okay. Do we have an x? Do we have an x as an exponent? Yes, it's right here. X is right there, okay. So you're like, that's all it has compared to this one. This one doesn't have a bunch of stuff. Okay, but we still need our horizontal asymptote, which is y equals 2. So by looking at our parent function f of x equals base 2 to the exponent of x, what would be our horizontal asymptote? What do you guys think? Who's got it? What do you think, Esmeralda?
Is it 0?
That is correct. Show me hands if you see it. Why it's 0? You guys see it? Okay, let's find out why. Well, look, here's the base, here's the x, base and x. It doesn't have an h, no. And what is our constant? Does this one have a constant after the exponential expression here? No, that's why it's 0. So let's plot a 0 here. And let's sketch our horizontal asymptote. So that means our graph is going to get really close to this, but never intersect our asymptote. There it is. Okay.
Wait, Mr. Key, can you explain why it's 0 again, please?
Say that again.
Could you explain why it's 0 again?
Okay, yes. So if I was to write this underneath here, watch. Okay, what's missing? It doesn't have an A, it doesn't have an H, and it doesn't have a K right there. And what do we know about K? Well, according to the general rule that we wrote earlier, right here, what did we say K was? Our horizontal asymptote. So if this doesn't have a constant or a number by itself at the end, does it have a number by itself over here after this? No. So if it has nothing, that's why it's 0. You see it?
Yeah, thank you.
Okay. So let me erase this from here. All right. So now that we're done with that, let's get started in filling in our table. Here we go. And this is where all the practice that you, yeah.
Que tienes, porque puedes poner tu.
What?
No, my mom was asking me a question. I'm sorry.
Oh, okay. To the, okay. Oh, I thought you were like asking a question about the graph. All right. So we're gonna fill in this table using these values for x. So notice I wrote f of parentheses equals 2 to the exponent of a parenthesis. So what is my first value? My first value is -2. -2, -2. So I'm going to use this one and I'm going to write it right here so you guys can see. So we got 2 to the -2. Can we leave it as a negative exponent? No. So what does that become?
Be 1.
1 over
2 to the second power.
which is,
4.
thank you, 1/4. Yes, that is correct. You're like, oh, that's why you did it, Mr. Gear. Yes, that's what I did it. Everything was a plan. So we have 2 to the -1. What does that become?
1/2.
1/2. 1/2. Okay. F of 0 equals 2 to the 0. What is 2 to the 0, Mia?
1.
Let's go. Next, F to the 1 equals 2 to the 1. 2 to the first power is 2. So let me, if you notice here, 2, -2, 2, -1, 2, 0, 2, 1. 2 to the second, well, that's 4. And 2 to the third is 8. All right, let's plot our parent function. -2 and 1/4. -2 and 1/4 is very close to the asymptote right here. -1 and 1/2. -1 and 1/2 is halfway right there. Okay. 0 and 1, 0 and 1. 1, 2, 1, 2. 2, 4. And 3, 8. Okay, let's graph our exponential function. There it is. There you go. So students, exponential function students. That's what the graph looks like. Now guys, like I said before, this is the basic or the most used exponential function. Now it's used everywhere, guys, on a daily basis. They use it for business transactions. They use it for predictions in regards to bacteria, in regards to other things. Kind of like last year when COVID hit like everywhere. I remember that some mathematicians came up with a formula that predicted like the spread of the virus, and they used some form of exponential function. Now, not exactly this one, but I'm saying they use some form of it. Okay. Now, for the purpose of this activity, now that you know what the parent function looks like, okay, I want us to focus on 3 points, okay? So I want you to go to your graph, this graph that we just did, and I want you to go to the point -1, 1/2, and make it a little bit bolder. This one, -1 and 1/2, make that point bolder. 0, 1, 0, 1, make that bolder. And 1, 2, 1, 2. Those 3 points. So we're going to move our function using those 3 points. Those are our handles in order to move the function according to the transformations that they give us. Okay, but I do want us to walk through the process to make sure we got it. Here it goes. So we're done with our parent function, f of x equals base 2 to the x power. So let's go to the next part, part B. It says g of x equals 2, base 2, and x to the -1 exponent. Well, in order to graph this, I still need an HA, or my y equals to, or my asymptote. Look at this form and look at our general form. What would be our horizontal asymptote for this one? Got it. 0. Let's go. 0. Why 0, guys? Because it doesn't have a constant. Does that make sense? Yeah, it doesn't have a constant.
Está bien. ¿Qué horas?
Alberto, you're unmuted again. Cuando guste, señora, siéntese con nosotros para que se aviente una sesión de álgebra 2.
Es que lo estoy invitando a un seminario, pero pensé que tenía se ha apagado el micrófono.
No hay problema. Mucho gusto en oírla. All right. So here we go. Y'all ready? So we're going to take these 3 points and we're going to look at this through this lens. We have the base, which is 2. We have an x. Do we have a minus? Yes. So question. What direction is this going to move the original function? Look at it. Don't say it out loud. Some of you already got it. Let's see. Let's ask somebody that we haven't asked before. How about Jaziel? Jaziel, which direction is this going to move the original function?
To the right one.
Let's go. Hands if you agree with Jaziel. Yeah, 1 step to the right. And why did she say that? Well, because we have this 1 right here, which is our h, and it looks like it's going to move to the right 1. So this is what I want us to do. Let's get these 3 points and move them 1 step to the right. So this one, 1 step to the right is about right there. This one, 1 step to the right is about right there. And this one, 1 step to the right is about right there. So that's our prediction. Yes? Okay, let's see if we're right. So let's do the work. I'm going to write this down here. So I'm going to write g of equals 2 parentheses minus 1. So what's the first value? The first value is -2. -2. So what is here in the exponent? What is -2 and -1? That's -3. So 2 to the -3. What is 2 to the -3? Well, we need to send it to the denominator, change it to a positive, and 2 times 2 times 2 is 1/8. 1/8. Yes. Okay. Next, g to the -1. So that's 2 to the -1 minus 1. So what is -1 minus 1? So that's 2 to the -2. And what is 2 to the -2? Addie?
1/4.
1/4. Yes. Okay. Next, g to the 0 equals 2 to the 0 minus 1, which is 2 to the -1. 2 to the -1. Oh, we already have it over here. Yes, 1/2. 1/2. Okay. Next, g to the 1, which is 2 to the 1 minus 1, which is 2 to the 0. We already have 2 to the 0, which is 1. There it is. G to the 2, which is 2 to the 2 minus 1. That's 2 to the first, which is 2. Okay. And last but not least, g to the 3rd, or g to the 3. I'm sorry, g of 3 is 2 to the 3 minus 1, which is 2 to the 2nd, which is 4. All right, let's plot these. -2 and 1/8. -2 and 1/8, that's very close to the asymptote right there. -1 and 1/4, also very close to the asymptote. 0 and 1/2. Well, what do you know? Did we have that point already? Yes, Mr. Q, right there. How about this one? 1, 1. Yes, we already have it. How about 2, 2? Yes, we have it. So this one, 3 and 4. 3 and 4, which is right there. Okay. So if I was to ask you guys, look up, what did this one do to the original? What would you say, Alberto? What did this one do to the original parent function?
It moved it once to the right.
So that, so let's show that right here. 1 to the right, 1 to the right, 1 to the right. So let's just show with an arrow. 1 step. Yes. Okay. Yeah. All right. So I think we're in a good direction. Let's go to our next one. Part C. Before we start graphing that one or making predictions, here you go. We still need a horizontal asymptote. By looking at it, what would be our horizontal asymptote, Christopher?
-5.
-5. Hands, if you agree with that, yes? Yes, because it's got the constant of -5. So let's go to -5, which is down here by your point. And let's sketch our horizontal asymptote. There it is. All right, so let's make a prediction. Let's see. Look at this.
Mr.
And
Q, I have a question.
Yeah.
For -5, why isn't it vertical? Because it's K. Or am I mixing up the two?
Let's go back to our form. Let's see.
Okay, I mixed up K and H. Sorry.
Yeah, remember on the previous one on rational expressions, the H was a vertical, which was a number next to the X. Yes. Let's see, where are we at? Oh yeah. So let's look at this. We're focusing on the original parent function, which is f of x equals base 2 to the x. Now we have more transformations on this one. So what will happen to the original black function that we sketch first, the parent function, according to these transformations that we have here? Do they have the same base? Yes. Do they have an x? Yes. But this one has a number there and a constant at the end. So let's see. Let me, Jaziel, can you pick someone to see if they can tell us what would be the transformations? All right, good. Thank you for picking Ivan. What do you think, Ivan? Okay, Alejandro. What do you think, Alejandro? What's going to happen to the original function?
What was the question again?
What's going to happen to the original function according to this?
I think it's gonna decrease.
Okay. Angie, help him out.
It's gonna go down 5.
And what else? Because we're focusing on the original one, on this one. So we got the down 5, yes. What else? Octavio, what else?
I think it'll compress.
Remember, compress is this one. And B is just the base for right now.
Would it go down 5 and move to the right?
Yeah, move to the right 1. That is correct. So let's take these 3 points, move them 1 to the right and 5 down. So this one's at -1, 1/2. I move it 1 to the right and then 5 down. 1, 2, 3, 4, 5. This one, 0, 1. We're going to move it 1 to the right, 5 down. 1, 2, 3, 4, 5. And this one, 1 to the right. Well, the point 1, 2 is moving 1 to the right, and 1, 2, 3, 4, 5. All right, that's our prediction. Let's see if we're right. Here we go. So I'm going to take this. Now, I'm not going to do the work. Well, let me show you the work for the first one. G of equals parentheses 2 to the exponent of x, and I'm going to leave it at blank, minus 1, close parentheses, and at the end, minus 5. My first value is -2, -2, -2. So this is, let's see, 2 to the -3, which is 1/8. But at the end, I need to subtract 5. So I have 1/8 minus 5. 1/8 minus 5, which is -4 7/8. Now I showed you the work. However, if you notice, isn't this inside of the parentheses the same as this previous function? Yes. So what do we do at the end only? Subtract 5. So watch. I'm going to take my first value here was -8. I'm sorry, 1/8 minus 5. What would be my next value? 1/4 minus 5. What is 1/4 minus 5? -4 3/4. What's my next one? 1/2 minus 5. That is -4.5. What's the next one? 1 minus 5. That's -4. What's the next one? 2 minus 5. That's -3. And the last one, 4 minus 5. That's -1. All right, let's graph that. -2 and -4 7/8. -2, -4 7/8. It's very close to the asymptote. -1 and -4 3/4. -1, -4 3/4. 0 and 4.5. Hey, we already had our point there. Good prediction. 1 and -4, same thing there. And 2, -3, same thing there. And the last one, 3, -1, 3, -1. So there it is. So let's see if we got it. We did these three. First, we started with our parent function, and then we added some transformations. Now, what is the first thing we do anytime that we're going to graph? We need to identify our horizontal asymptote, which is our what? Our k, or our constant. From there, once we graph it, we look at the next graph that they gave was already transformed. So I asked you guys what happens from this black one to the red one that we graphed. And Alberto said, I said, what would be the general idea? That it moved the whole thing, and we saw here with arrows, one to the right, because it only had that one transformation. From there, we did the blue one, part C. We found our horizontal asymptote, which was a constant of -5. However, it still had those transformations. What were the transformations? And then we said that it was 1 to the right and 5 down. So we took this black original one, 1 to the right and 5 down, and we ended up over here. However, we did the computation just to see if it was true, and it was true. Okay? So guys, quick introduction. Exponential functions, student exponential functions. So for your asynchronous, you're going to do one more. That's, if you notice, the base is a fraction, but you're going to do that by yourself. However, just one more thing that I want you guys to do, an observation. Now, this one a little bit longer than I usually did with the other classes, because you guys need to stay focused, guys. You guys need to stay focused. My goodness. I was about to send Mia to slap people around. My goodness. Copy this table, please. And it says, example 3, what happens to the graph of the parent function f of x equals bx, or I'm sorry, b to the exponent of x, given g of x equals a times b to the exponent of x minus h plus k, give the general exponent function with all the parameters. So your table on the left side, the first column, you have an empty space first, and then it says the next row, leave about 2 or 3 lines. It says greater than or equal to 1, leave a space, and then less than or equal to 1, and then another space, and then 0 at the bottom. So it's 3 rows down. And then you move on to the right. First column is A, parameter A. Next column is B, parameter B. Next column is H. And the last one, parameter K. All right. So I'm going to give you, copy that for a little bit, and then I'm going to get you a code because we're going to do a quick activity on Desmos to make sure we see what I wanted you to see in regards to the transformations of an exponential function. Okay. All right. So now once you copy that, here we go. I want you to open up a new browser on your computer or your electronic device. And I want you to go to type in the browser student.desmos.com. And then your code is H7MT8S. And then you're going to log in with your first name and your last name. Do that right now. So basically what you're going to do in Desmos, I included an activity where you move each lever like we did in semester 1 with some other functions. And you're going to answer the question, what happens when you move the lever for A when A's value is equal or greater than 1? And you're going to write here, oh, it does this to the graph. If it's less than or equal to 1, it does this to the graph. If A is 0, then it does this to the graph. You're going to do that for each of the parameters. Once again, here's the code again. H7MT8S. I see some of you are already in there. Hurry up, please. Now, it's going to look something like this.
Mr. Q,
Yes,
the page is blocked for me.
blocked.
Yeah, like it says iBoss page error. Like
Oh.
when it blocks a page.
Yeah, I don't know what's going on, but for that code issue, you should be able to go in.
No, it doesn't let me.
Okay,
Use capital. You gotta
Use-
use capital.
Capital. Oh, for the code?
Wait, Mr. Q, what's the code again?
The code is, give me a second. H7MT8S. H7MT8S. 8S. Make sure you write it down. All right. So once you're in, guys, once again, notice here's the graph. Here's the exponential graph. You can zoom in or zoom out, play with it. However, move each of the levers, start with A, and see what it does to the graph when it's equal or greater than 1. Move it to the right, less than or equal to 1 to the left, and see if you get it to 0, what it does, and make your observations, write them in there. Now, if you want to be writing as you see it move, then you can press play here. I included a button on the left side here. Do you guys see it? Right there. Each of the parameters has a little play button that you can press in, and it's going to make the graph move as you're taking notes, okay? So I'm going to go ahead and log off from Zoom, guys. That's going to be our session for today. Make sure you do your home play, do the practice. And tutoring at 1:15, I need to pack up and head to the high school. So if you need that extra support, be there or be elsewhere. All right. Have a good one, guys. Enjoy your home play. Make sure you finish this activity. I'm going to be checking that you are logged on and doing this activity. Okay. Have a good one, guys. Peace.
Bye, Mr. Q.
Bye.
Mr. Q.